Hello, this is Fereidoon with another lesson on electricity. This topic is about atoms and electrons and protons and all the particles inside them. By the end of this session, you should be able to understand what is meant by charge, understand and recall what parts of the atom have charge, describe how objects with charge can be moved, explain some of the differences between a conductor and an insulator, define what is meant by current. Charge is a fundamental property of the particles that make up atoms. Like mass and energy, charge cannot be destroyed, made, or just lost. Charge is measured in coulombs, or C for short. In the modern view of the atom, there are three particles. In the center of the atom, the nucleus, there are protons and neutrons. Orbiting the nucleus are electrons. Only protons and electrons have charge. In fact, they have the same amount of charge as each other, but they differ in sign. How much charge is charge then? An electron has a charge of minus 1.602 times 10 to the power minus 19 coulombs. Neutron has no charges. Proton has a positive charge of 1.602 times 10 to the power minus 19 coulombs. Therefore, they're balancing each other and keeping the whole atom neutral. Something that has charge, proton, electron, or ion, makes an electrical field around it. Electric fields affect other charged objects. They make them experience a force. Forces can move stuff. In a fluorescent tube, electrons are emitted by a heating element at either side of the tube. The electric field in the tube causes the electrons to accelerate down the tube. Conductors and insulators. The key difference between a conductor and an insulator is how easy it is for charged objects to move through them. For the purposes of electricity and simplicity, we shall only consider electrons. In the image to the right, there are two materials: copper, the wire, plastic, the protective covering. Copper is full of electrons that are free to move about, whereas plastic doesn't. This means it is easy for electrons to move through copper, but very hard for them to move through plastic. A flow of charge is called current. Current is measured in amperes or amps and is shown by capital A for short. A current of 1 amp is defined as being equal to a total charge of 1 coulomb flowing past a point in 1 second. Therefore, you can write the equation I equals Q over T. Q is the charge measured in coulombs, T is time measured in seconds, and I is current measured in amps or amperes. Some examples here. The answers are there, but you can practice yourself. If a total charge of 0.5 coulombs flows past a point in 0.0025 seconds, what is the current? So you just put the values in the equation. I equals Q over T. Therefore, 0.5 over 0.0025, and that gives you 200 amps. If a current is measured to 4 milliamps, how long will it take a total charge of 8 microcoulombs to flow past the measuring point? I equals Q over T, therefore T equals Q over I if we transpose for T. And therefore you put the values there, 8 times 10 to the power minus 6, because our value of charge is 8 microcoulombs, so micro is 10 to the power minus 6, and 4 milliamps current, that is 4 times 10 to the power minus 3. Therefore, the answer, the time is 2 times 10 to the power minus 3 seconds, or 2 milliseconds. If a current of 13 amps is measured for 5 minutes, how much charge has flowed past that point in total? Again, use the same formula. We just transpose for Q. Q is I times T, and we have the current in amps, 13 times 5 minutes, so we have to convert that to seconds. 5 times 60, and that will give you 3,900 coulombs, or 3.9 kilocoulombs. Thank you very much, and I'll see you again with another lesson. Goodbye.